the nervous system of your horse and your nervous system your friend or your enemy? That is a crucial question to ask yourself when you interact with your horse. So, why is it so important to know and really understand, gather knowledge, and apply that knowledge in horse training? There are basically two things which are very essential in horse training. One is learning. You learn, your horse learns. And the other one is movement, because whatever we do with our horses, movement is always involved. And our brain is and our nervous system as the information system of our body are actually what connects us to our environment and to our reality and how we perceive life and what we do with it. So the nervous system is actually consists of your brain. So your brain is not separate from it, it's part of it. So you have your brain, your spinal cord, and the peripheral nerves. And the brain itself in the skull doesn't know what's happening. It only knows it because it's receiving information via our senses, and that information which comes in our senses is transported via neuronal pathways to the brain so that the brain knows what's happening. So our senses and the communication via the nervous system is actually informing our brain, and our brain then decides what to do, how to react, what's the most important thing right now. And the most important thing for sure is to secure our survival. So the brain actually, what does it mean to secure our survival? Means one part, it means like to react to external stimuli in our environment. So that might be, for example, your horse is half sleeping in the sun on a very hot day, and the body temperature gets too high, or the horse starts to be dehydrated or something. So the brain will gather that information and then send like information via the nervous system to the body to move the horse out of the sun, maybe in the shadow, or maybe go and search for water somewhere. So, and there we have like a good combination of external stimuli, so move out of the sun into the shadow, and internally as well, the brain permanently reacts to internal stimuli. So, for example, oh, my cells start to be dehydrated, I need to get water. Or digestion, how your organs function, your breathing, your heart rate, everything is controlled by the nervous system and the brain. So you could actually literally see it in the way that each cell of your body is permanently communicating with your brain via the nervous system. So, two very, very big aspects of this thought are the brain is responsible for our security and it is responsible for our health. So, in general, when everything is fine, and this is all nicely regulated in balance with our body and our environment, the brain can do that job to keep us healthy and everything is nice. So it takes care of all metabolic processes of your healthy organ function and all these things, building new cells, like getting rid of waste products, all these things are orchestrated by our brain. And now it might be that this gets out of balance because there's a threat from somewhere. So let's say the predator jumps out of the bush. What happens now is that because of the sensual input, a predator is jumping out of the threat. So visual and auditive stimuli are transported to the brain. The brain says like, oh, danger of survival here. So we need to react. So a stress mechanism will be initiated. And what is stress? Stress is not only this abstract thing of, oh, I have my to-do list and I have so many things I have to do, like how we stress as people. Stress is literally a survival mechanism. So we have different survival mechanisms. And so stress in itself is actually something good because it secures our survival. And we have these very known survival mechanisms, stress mechanisms. One is flight, one is fight, one is freeze. And in humans, we have fawn, but fawn doesn't count for horses because fawn is something where we have an adaptive behavior out of something from the past where we thought about how we did in the past and adapted our behavior to have a potential different outcome in the future. And all that asks of a brain a cognitive process which the horse's brain is just not capable of doing in that way. So the horse has those three physiological stress responses at first, which is flight, fight, and freeze. So flight, very obviously, is I move away from a stimulus. So there's a potentially dangerous stimulus coming in, and I move my body away from that. Fight is when I cannot move away, I fight against that stimulus. I try to get rid of it by fighting it. And freeze is called the immobility response as well. So freeze is when nothing has worked, I cannot run away, I cannot fight, and the stress gets too much for my organism. Actually, I get immobilized via the nervous system. So we all know this example of the antelope, which is like caught by a lion and then it's hanging there as if it's dead, but actually it's not dead, it's in freeze. And then when the lion puts it aside and I don't know, continues chasing other antelopes or whatever, very often they jump up and just continue their stress response before the flight, for example, and they just take off and they survived. So freeze is a very, very crucial stress response as well. And what is happening actually when a stress response is triggered is that we have two branches of the autonomic nervous system, the autonomic nervous system being the one we cannot voluntarily influence, which is sympathetic and parasympathetic. And we have a type of range. When we talk about sympathetic and parasympathetic, people think excuse me, parasympathetic is rest and digest, and sympathetic is all the more stressy stuff. And actually, that's not quite right. We have a spectrum during you have this range between a very high aroused sympathetic and a very, very switched on parasympathetic. And we are somehow moving in this spectrum the whole time. And there's a range in the middle where we could say we are regulated. So, for example, in the morning when we get up, we need a sympathetic arousal. If not, we wouldn't get out of bed. If we would stay just in parasympathetic, we would be lying there doing nothing. Or, for example, something falls down and you have a quick reaction to catch it. That's a sympathetic response. So during the day, what we need to understand is we are moving up and down in this range the whole time, moving between parasympathetic and sympathetic, and we are somewhere. And for stress, there is just a certain arousal state where what we call really this negative stress starts, where we have like really a type of survival stress, which starts where actually we cannot, survival gets more important than what we've been doing before. So, for example, if I'm very, very stressed, actually my capability of thinking about something will diminish because the blood flow in my frontal lobe will just go down because my body is preparing me for a survival mechanism like flight, fight, or freeze. In that case, for example, to be capable of getting away from somewhere, I need very capable limbs to do that. So the blood flow, the sympathetic response will actually prepare the body for the stress response to be capable of kicking in flight or fighting, for example. So it is a very, very good system actually for our survival. It's just like we need a balance. So we can get up there, but we have to be able to come down as well again to keep actually the body in a healthy state. So what is said usually is that it would be good to be at least 51% in parasympathetic, so that all the repair and recovery and building new cells, restoring the body, and so on, that all of that can have function in a healthy way. So each organism actually can handle short-term stress. So, like you cross the street, someone is banging on the horn of the car, and you're jumping to the side, you won't die of that. It's like you can handle that because then afterwards you just continue. Your breathing goes down again and you're fine if you can regulate. So, to understand that is if you want to, sympathetic arousal prepares you for stress, for survival mechanisms, stress mechanisms, and parasympathetic like regulates all your metabolic function, your healthy organ function, everything which is, yeah, building new tissue, all these things which happen the whole time in our body. So as long as we can regulate back into those states um, from a high arousal, come back down, we're good, we're fine. So for making all this happen, we need energy. An organism needs energy. So that's why we eat. That's why we have to bring energy in. And if we think of what the nervous system and brain use as in percentage, it's like it's very known from the human research with horses. It's like most probably quite similar. So it's like 20% of all the energy intake you have via your nutrition will be used in the brain. So that's quite a lot of energy. And what is really important to understand is if we think of horses, there is not that much energy available in the nutrition they find in a natural surrounding. So the organism tries to not waste that energy for unnecessary things. So, for example, if certain things happen very often, or there's routines and there's things which always happen in the same way, the brain, because of not wanting to use very much energy, has the tendency to create patterns to automate behaviors. So, what happens when to explain to really understand what's happening, it's like think of when you learned how to drive a car. You had to, so what's happening actually is you have some sensory input. For example, you see a red street light, for example. um, then that information is sent to the brain, and you learn that, oh, if that information comes in, I need to move my foot from the gas pedal to the brake. If you, or maybe if you learned like in ancient times, like there's a clutch and so on. So you have to you connect a certain stimulus with a certain motor response in that case. And if you do that very often, so you have nerve cells which fire together in a certain frequency and so on, and you build different types of nerve cells fire together, and what you create is a neuronal network. So that neuronal network will actually, if it's used over time, first, when you build a new one, it takes a lot of energy. That's why learning to drive a car was a lot more energy consuming than driving a car now. So, what happened is because we've done these things repeatedly again and again, oh, this is happening more often. So, we need this pathway of neurons firing together more often. What the body does, it's putting myelin around it. And the process of myelination is actually, you can imagine it like you have impulses like in an electric cable, and if you have no isolation around the cable, a lot of the charges will just go somewhere and not where you want it to go. And that's exactly what the brain does with myelin. It isolates, kind of, if you think about it in a simple way, it isolates those pathways in a way that the information is really direct on that route, because it's a route which is important because you use it very often, and that creates a neuronal network and a pattern actually of functioning. So if you think of your horse, for example, something external the horse might have learned is this typical thing. You pick up the hoofs and you clean the hoofs, and maybe you always do it in the same order. And then when you pick up the front leg, you move towards the hind leg, your horse already lifts the foot. That's like automated because it's just always happening like that, for as an example. So the brain actually has these patterns to use less energy when those things which happen on a regular basis happen. So the brain is actually built by how it's used. So how to create those neuronal networks and where they create and in which way depends on how it's used, but it's like kind of happening in the process. So if we connect those by learning, that's very explainable with like driving a car. But when we're born, um, we create neuronal networks the whole time in the beginning as well. If we look at fillies, for example, if we really look at newborn horses and like then the young horses, when we look at how they are moving as well, they are learning patterns to move. In a human, it takes a lot longer, but we have as well these phases of crawling and so on. That's actually our body creating a neuronal network to make our body movements function. So, and to control them in a better way. So when you see fillies, newborn horses, when they get up, they are quite capable, a lot more capable than we are when we're born, but they look a little bit clumsy in the beginning when they're with all these long legs, and then they're like, they make a movement and it's like they want to stabilize and it's woo swinging, the movement is too big or not big enough and so on. And this is actually because they do not yet have those pathways of no neuronal networks which function well, and by learning and moving, actually, they start this myelination process in their brain to have those patterns available and as well to go from very a little bit clumsy motor function to a more refined and better controlled motor function. So this process of the brain, which is happening throughout our whole life, this building and adapting, is called neuroplasticity. And it is really the brain is capable and does, and this is really important to understand, your brain is changing and evolving and developing on a regular basis throughout your whole life, functionally and structurally it's changing. And that is like what neuroplasticity implies. It is your brain is an organ which is changing the whole time, functionally and structurally. So when we think of training horses now, it's very obvious that learning is a very huge part of horse training. So in what state, if we think of nervous system, understanding the nervous system better, in what state does the nervous system have to be for a horse to be capable of learning appropriately? And very often nowadays, I see that people think because maybe some outdated horse training methods were not so nice and so on, that people think, oh, I want my horse to be relaxed the whole time. I just want my horse to always feel good with me and never have stress and so on. And that's actually very wrong because to be capable of thinking about a stimulus and interacting with a situation, and as well being in a situation where I need to find a solution for a certain task or a problem, I need a certain level of arousal. And what is actually the way you want to have your horse is if you think of sympathetic and parasympathetic and this range of where you're like regulating between the two, you need a certain arousal for the horse in that case to even like interact with that situation and the stimuli. And it is very, very individual. There are horses you need to really bring up quite some so that they start looking for solutions. And there's others who will be so over aroused that they cannot learn anymore. And you need to pay more attention to keep them under that threshold, actually. So knowing your horse's stress threshold to where can it still think, where does it not think, or where is it too little aroused to even consider doing something and thinking about the task at hand. So this is very individual, and for that it is obviously very, very important to learn how to read in what state your horse is. So, and you have yeah, certain markers. You have mimic, which nowadays you find a lot as well, everywhere information about how can I see in the face of my horse, how does stress show up in his mimic, how does stress show up in the ear play, how you can observe the breathing. How does the breathing of my horse change in different states of arousal and so on? And for sure, you have body posture as well. You know, there's sympathetically aroused muscles, and there are others which are more parasympathetically aroused. And depending on how your horse carries itself in a certain moment, you can start to read like, what state is my horse in? And I always have the tip for people if they are unsure about when they present a new situation, something new to their horse, um, try to figure out how long is my horse curious. Because curiosity involves a certain state of arousal, but your internal attitude towards something is still towards it. You know, it's like oh, it's strange, but I want to look. I want to know what that is. So curiosity gives you an inner state of towards something. While when you are at that threshold of stress where the horse starts to say like, oh, maybe this is dangerous, then the body will start to say, let's get away from it. So the moment your horse is like in a, I want to be away from something state, most probably you're over the threshold. So play with that a little bit. Like, look at where can I really see that? How can I read my horse in that? So curiosity is important. Another thing which you will improve if you start like really reading the state of the nervous system of your horses, you will improve your timing in everything. You will improve your timing in your requests. You will improve your timing in your aids, whether it's written or on the ground, it doesn't matter, because you will communicate with the horse and the state it is at right now, if you can read it. And that will make most probably how you introduce certain cues. It will slightly change your timing, even in things the horse already knows. You might feel a difference in that. Another thing about timing is the pause, the always underestimated pause. How often do you give your horse a break so that it can really consolidate and have this information going there and really give it the time to process? How long is the pause you're giving your horse? And do you put interfering stimuli inside of the pause, or is it a real pause? Because a real pause means nothing else is happening. So the pause is a very, very important thing. Another thing concerning timing is, when do I stop? Because if I'm presented with new stimuli, there's a certain amount of stimuli I can process in a good way, and then I have information overload. So when do I stop my training session? How long do I make my training sessions? How many new things do I present, or do I just present two and then we're off and go for a walk or hang around together and have nothing time or something like that? So really considering the capacity of your horse for concentration, basically. So, and the horse is always, always learning as we are. And if we think of the nervous system perspective of this whole horse training question, I need to bring you some news. Your horse lives literally in a different world than you do. Think of the senses. So, how you perceive the world, it's like the environment, how it really depends on how you perceive it. I'm not talking of judgment about it. It's a good, it's a bad place, whatever. I'm talking of what your senses sent you. This is green, this is brown, this is red. The horse has a visual sense of 350 degrees. If it turns the head, it has a visual sense of, say, 360. And it doesn't have depth perception on a very big area of that visual input which comes in. That's one thing. And another thing is, um, if you think about nervous system and the amount of stimuli coming from the outside in the brain, which the brain has to process, you can imagine that our visual sense, which is like, here I'm not seeing my hand anymore, there I start to see it, it's like the spectrum, what we see, and the amount of stimuli which our brain has to process coming in from our eyes, it's a very different amount of stimuli I have to react upon or not, depending on what my brain says. If you think of hearing, our ears are quite fixed. I mean, there are some people who can wiggle them, but we do not have these ears which can just like change direction and so on and hear from, say, like really make the sound come in different ways. We cannot do that. On the other hand, our brain is capable, when we hear a sound, our brain is capable of calculating up to 1 degree of 360 where it comes from. A horse's brain, ear-brain connection, information flow, can only do that to a precision of 30 degrees. So that's like really not very precise. So, for example, if it's windy and there is more sound than usually, that can explain why a lot of horses are a little bit more stressed, because there's a lot more stimuli coming and they can't really say from where it is. So the further away a sound is, if you think of 30 degrees, which is like kind of a lot, I think, yeah, it's very unclear actually. So sound perception itself is very, very different. Then we have the vibrissae. So these it's sensual organs which we cannot even imagine because we don't have them. So it's sensual organs where the horse gets information from the whole time as well. So tactile information. So your horse literally lives in a different world than you do. And that is important because perception makes up how you interact with your world. And talking of perception, we have to think of movement as well. And to be capable to move, I need to be capable of perceiving my body. I need to know where my body is in space. And this type of perception is called proprioception. And horses, as sensory motor beings, they are, I mean, us as well, but I think for horses as a prey animal, that's like more prominent as well. They are really, really depending on feeling well in their body and being capable of feeling their body well. So, what does that mean? Proprioception, how does that work? The fact that I can, even when I close my eyes, know where my left foot is because I have receptors on my nerve cells everywhere in the body. There's different types of mechanoreceptors. We don't need to go in detail. Proprioceptors, which send information via the nervous system to my brain, where a certain body part is, how much pressure there is, how much flexion in a certain joint, like all the information about the position, the tension, the forces acting upon my body or not, all these things, they are sent permanently to the brain so that the brain knows where the body parts are right now, which is essential for moving. And it's actually depending on the information coming in. It's again the brain initiating reactions of the body. So, for example, if you're standing on one leg for a very long time and there's a lot of compression and all these things, and then maybe the tissues there, send information to the brain and it will make you switch leg after a while without thinking about it. Because the information is just like, oh, this is a little bit too much strain here. And as the brain wants to protect you from injury as well, so from breaking your body or body parts, it will make you react to that. So that's that part of reaction is like, actually, am I capable of activating? So you have this information coming in from the body to the brain, proprioception, and then you have the brain giving information to the body, like activating certain body parts for a reaction. So these different directions of that communication, brain body, you need both. So if everything is nicely in balance and we're good, fine, that's fine. But as we all know and might have experienced in our life, there are sometimes things not going that well. For example, what can have a huge influence on movement is pain. So when we have pain, for whatever reason, our proprioception, so usually we have this information coming in via proprioreceptors, and now we have nociceptors. That is, nociception is actually our perception of pain. So it is important to understand that when we have pain in a certain area of our body, or our horse has pain, the nociception is always overwriting the proprioception. So it's like you have the proprioceptors try to give information. Now there's nociceptors. That information will always be more prominent in the brain because it is more important, because it's more dangerous, because the brain says, for example, if you continue to move like you did, and there might be a strain on a certain tissue and there might be injury, and I want to protect you from that. So nociception is something which influences a lot how we move. Obviously, pain influences how we move. So when I'm in pain, I will start to move differently. My horse will start to move differently. And we call that a compensation pattern. So the horse will move its body different than it did before because it's compensating for a certain area in the body which is not functioning that well because of injury, for example. So you have a lame horse, it will move in a compensation pattern. If we have compensation patterns for a very short period of time, in general, then it doesn't cause such a big problem. But if we have compensation patterns over a longer period of time, and that period of time is very individual, but it's a lot shorter than what we think, then we're fine if it's very short. If a compensation pattern lasts longer, as we have a brain which is neuroplastic, which is changing and adapting by how it is being used on a neuronal pathway point of view, the compensation pattern now might become the primary movement pattern the body chooses because it's just learned so well. So very often we have that we think, oh yeah, after an injury, the horse will move like before. And nope, that's not always the case. And another thing to understand nervous system wise concerning movement is that lack of movement as well leads to, for example, if I have like, I move my wrist and I have this is, for example, my full range of movement in this movement direction, but I only use this. Then I have less proprioceptory input coming to my brain. And whenever proprioception is diminished, nociception goes up. That means I will feel more pain in the areas of my body where I move less. So lack of movement literally heightens pain in the body, pain perception in the body. And another thing lack of movement does is there is a factor in our brain which is called BDNF, and that is the brain-derived neurotrophic factor. That is a factor in our brain, a chemical which helps us, a protein, a thing which helps us connect neurons together. It makes it easy for neurons to connect well. So it enhances our capacity of creating neuronal pathways and networks throughout our brain. So despite sleep and other good nutrition and other aspects, movement is essential to build BDNF. So if I have lack of movement in my horse, it literally takes away from the brain capacity of my horse to create neuronal pathways in an easier and better way. So you could say that lack of movement makes your horse less capable of learning and a little bit dumber, maybe. So that's the aspect of movement. Another area is for a regulated nervous system and for the good functioning of everything we want and for making it easy and fun in life, um, we need to look at all the other aspects which create stress because, as I said, short-term stress, no problem. All organisms can handle short-term stress. That's actually supernatural to have short-term stress because we have that as a survival mechanism to change our circumstances or our behavior or whatever to be in a better way. So short-term stress, good thing, no problem. Whenever stress becomes chronic, then it is a problem. We looked at the physical side of it, but on the mental side of it, you could call it, check the housing of your horse. Like herd constellations where there's permanently horses which don't like each other being put together outside. All these things like feeding time. There are not enough, for example, when they live outside somewhere and they have these hay stations and there's not enough places to eat for horses and they need, whenever there is a feeding moment, they're stressed because they're being pushed away or stuff like that. So the housing of the horse, the herd constellation, all these things can create a lot of long-term stress, which sometimes we're not aware of because it might as well conflict with our understanding of what we think is good, a good way to house a horse. And maybe for that individual horse, it's not the best way to do. So these things. And once we get in that yeah, downward loop, we are in a dysregulated state of the nervous system. And for sure, dysregulation can over long term be learned as well. So for example, if you have horses, some of us have our horses not from since they are born, but we get horses when they're already quite advanced in their age, or they had like several owners before and stuff like that. So you don't know actually how that horse in that particular setting is. And to yeah, to look at all these aspects is essential for understanding why our horse is in the state it is in on a regular basis. So that's all the external factors we have to look at. But then there's for sure the factors of what are we doing with our horse? Because training, um, I think it's like obvious. Training, if it's not done in a good way for the nervous system, can be very stressful. So mentally, when I work with my horse, I have to check, am I asking too much? Am I actually stressing my horse because I am asking too much, too often, too whatever, much? If I'm asking too little, that can be very stressful for a horse as well, actually. Because if I continue to ask too little the whole time and there's never this arousal that I take care of it, I'm getting literally on the nerves of my horse. So um, all these questions, when I want something from my horse, does it understand my cues? Does it understand my vocabulary in the language I'm using with it? All these things are very, very important to consider. Physically, same thing. When I train my horse, is my horse actually physically capable of answering that question? Is my horse, not only from a training perspective of is it fit enough? Is it, we talked about activating muscles. Is it capable of knowing how to do that movement? So, for example, good example is sideway movements. A lot of people think the sideway movement will magically explain to the horse's body how to do this certain thing, how to flex this joint better or whatever. And I'm like, no, the horse needs to know how to activate a flexion of that joint to be capable of doing that movement, or an abduction of the shoulder, something like that. A lot of horses struggle because they do not know how to really activate certain parts of their body because they never did, they never learned, or they are stuck in a compensation pattern, or for whatever reason. And we continue to ask them those things. That creates stress in the nervous system. So it literally is very, very important to think about and to really look at, does my horse know how to do that. So all these questions we have to ask ourselves when we can consider, is my training actually helping my horse or not? The main thing is to learn to be aware of and consciously involve thinking about the state of the nervous system. Because back to the initial question, is the nervous system of your horse your friend or your enemy? That depends hugely on how much you know about the nervous system, how it's working in your horse's nervous system. How can I read that state in my horse? Am I really reading the right signs? Is my interpretation correct? All these things. How does this individual horse express stress? So where can I see that this threshold is like maybe overstepped? How do I come back from that? All these questions is something on a daily basis you have to think about while interacting with your horse. And so it's kind of like become the neuroscientist and observing there, like, because like take time, observe your horse, observe it when it's outside with other horses, how it's interacting, what's happening at feeding time in the stable, like just like be the observer, like find out, learn about that nervous system of this individual. And for sure you have a nervous system as well. So what state am I in is as important as thinking about what state is my horse in, because same thing here, we have a nervous system. And if we don't know and are not aware of the state we are in, we might have a very, very different way of interacting with our environment and with other living beings in it, be it human or horse, depending on our state. So think about that. Whenever two beings meet, if it's humans or if it's horse or if it's human horse, you have two nervous systems communicating with each other, and you have two nervous systems being in their state where they were before you met, and then the moment you meet you are reacting to each other, and that is co-regulation. So you can actually, if something is out of balance, you can help to regulate in a good way, or you can create more dysregulation. So befriend your own nervous system and befriend the nervous system of your horse, because that might be the piece which will completely transform not only your training, but as well the relationship with your horse over long term.